Hi everyone. In this section we are going to talk about chemical equations, and I'm going to show you a little bit about how to balance chemical equations. So a chemical equation is just a simple way of representing a chemical reaction or a chemical change. Whenever you have the chemical equation, the reactants are always on the left and the products are always on the right. You'll see an arrow in between. That's showing you the direction of the chemical reaction. Remember, most of these are not reversible, and so it's always going to go from one thing into another thing. In the chemical equation, the number of atoms on each side must be balanced. What that means is if you start off with 5 hydrogen atoms, you'd end up with 5 hydrogen atoms. That doesn't always work with the way that compounds form, and so we have to adjust the coefficients in the chemical reactions in order to adjust and make them balanced. To do this, you need to be able to count the atoms that are in each of these particular compounds. So I'm going to show you how to do that first, and then we're going to talk about how to balance some of these equations. For example, how many atoms of each element are in this given compound? Well, this is potassium nitrate. And so this K is potassium, and there's only one of those. And then there's one nitrogen. And now the subscript here means there are 3 oxygen atoms. And so this is what you would do to break down each one of the elements inside of a reaction. Let's try another one. If you see the parentheses here, this is implying that this number tells you how many of these there are. Okay, so what that means is there are 2 sulfate molecules and 4 hydrogen molecules. So there are 4 hydrogens. Okay. 2 sulfate molecules means there are 2 sulfurs. Okay, and there are 8 oxygens. Okay, having that subscript there is kind of like having this. We just don't write it twice like that. And because it's not an exponent like you would see in math, we don't write it as an exponent. We write it as a subscript. We're just saying that there's 2 of them. So let's look at some chemical reactions and see if we can figure out what numbers are missing or whether or not they're balanced. I think balanced is first. So to balance equations, you would add coefficients in front, right, until the number is balanced. So we want to see if these are balanced equations. And so what we want to do is basically, let's start with A. We have sodium, iron, and oxygen. And so I'm going to write sodium, iron, and oxygen. Whoops, just oxygen, just O. Now we just want to count. There are sodium ions here. Okay, there's only one, but then this number in front is just a multiplier. It's a coefficient. And so there's only one sodium, but there's 6 of these. So there's 6 on this side of the equation. With the iron, there's no coefficient there. So it's just 1. So there are 2 iron atoms, 3 oxygen atoms. Now, if we look at the right-hand side of the equation, I'm just going to change colors. Now there are 2 iron atoms. Here we have sodium oxide. There are 2 sodiums, and there's a 3 in front, so 2 times 3 would give us 6. And then there would be 3 oxygen atoms. And so, same number on both sides. This one's balanced. Let's try the next one. Just going to erase this. In the next equation, in B, we have manganese, oxygen, hydrogen, and chlorine. Mn, oxygen, hydrogen, and chlorine. On the left-hand side, we have 1 manganese, we have 1 oxygen, and then we have 4 hydrogens and 4 chlorine molecules. On the right-hand side, we have 1 manganese. There are 2 chlorines here and 2 chlorines here for a total of 4. There are 2 water molecules which have 2 hydrogens each, so that's 4 hydrogens, but there are 2 oxygens. So now this one is not balanced. Because there's the wrong number of oxygens on both sides. We could balance this, but it would take a little bit of extra work. We'd have to change more than one coefficient here. So let's try the next one. In the next example, we'll go through actually balancing one that's not balanced. And so we have then carbon, hydrogen, and oxygen. We start off with 4 carbons, 10 hydrogens, and then 9 O2, so 9 times 2 would be 18 oxygen atoms. On the right-hand side, we now have 4 CO2, so 4 times 1 will give us 4 carbons. 4 times O2 will give us 8 oxygens. Here we have 5 water molecules. So 5 H2s will give us 10 hydrogens. And then plus 5 more oxygens. 8 and 5 is only 13. And so again, here they're not balanced because there's wrong number of oxygens on both sides. And so again, here they're not balanced because there's wrong number of oxygens on both sides. Let's see if the last one's balanced. There we have hydrogen, sulfur, nitrogen, and oxygen. So we have hydrogen, sulfur, nitrogen, oxygen. If we start with the hydrogens here, we have 3H2, which will give us 6 hydrogens, 1 sulfur. We have another 2 hydrogens here, so plus 2. 1 nitrogen and 3 oxygens for a total of 8. Oh, I missed the 3 in front of the S here, so there's 3 of these. On the right-hand side, we have 3 sulfurs. NO is just 1 nitrogen, 1 oxygen, so there's 2 of each. Oh, I missed the, look at this, yeah, I'm missing a few things over here. Let's look at this one again. 6 hydrogens and 3 sulfurs. 2 hydrogens, 2 nitrogens, and 6 oxygens. Now on the right-hand side, 3 sulfurs. We have 2 nitrogens and 2 oxygens here. And then 8 hydrogens and another 4 oxygens for a total of 6. And so all of these check out. And this one, after a couple of mistakes, this one's okay. Be careful with those coefficients. It's easy to miss one. And so check what you're doing. Make sure that you're counting everything correctly. The goal is just to count the number of atoms and make sure that they're the same number on both sides. If they're not, you can add a coefficient to change it. Sometimes you have to add more than one coefficient, but we're only going to deal with adding one coefficient in the practice exercise that you do here. There is some extra credit, and if you follow these same steps, you should be able to accomplish those in lab this week. So, and that's all about balance and equations. Let's start here with the first example. We have iron, sulfur, and oxygen. Now on the left-hand side, we have 4 irons. We have 8 sulfurs. And we have 11 times 2, so 22 oxygens. On the right-hand side, iron, we have 4 irons, 6 oxygens,